Hello everyone, welcome back. Guys, topic for the day is VRRP. Today we will discuss VRRP protocol. In last class we had discussed HSRP. Like HSRP, VRRP is also a protocol which provide redundancy for default gateway. But as you know, HSRP is a Cisco proprietary protocol. So you can run HSRP on Cisco devices only. But if devices is non-Cisco, then we have one other protocol, that is VRRP, and you know VRRP is an open standard routing protocol, so you can configure VRRP on Cisco devices as well and on non-Cisco devices as well. So today in this video we will cover everything about VRRP protocol. First we will discuss something about theory part, then I will show you practically how to configure VRRP. Okay, but working of VRRP is same like HSRP, right? There is no any difference between use of HSRP and VRRP. The difference is like one, HSRP is an open is an Cisco proprietary protocol and VRRP is an open standard protocol. So you can run VRRP on non-Cisco devices as well, and you can run HSRP on Cisco devices only. Okay, so guys, first point is VRRP stands for what? So VRRP stands for virtual router redundancy protocol. Okay, now HSRP is an layer 7 protocol, right? Means all traffic of HSRP will be generated at layer 7 at application layer, but VRRP is an layer 3 protocol, so it is an layer 3 protocol. It is a network layer protocol, so traffic of VRRP will be generated at network layer at layer 3. So this is second difference. So if VRRP is an layer 3 protocol, then definitely there will be one protocol number of this protocol. So it uses protocol number. Protocol number is 112. So 112 is protocol number of VRRP, and as HSRP there will be one hello message, and hello timer is 1 second. 1 second means after 1 second router will send hello message in VRRP, and hold on time is timer is 3 seconds, and never will hold that information for 3 seconds. Okay, and it uses multicast address that is 224.0.0.18. fine. After that you can mention some more point here, that after with okay, you can mention some more point here, that after election of master and standby, master and backup, here one router will become master and one router will become backup. Okay, so after election only master router will send hello message. Only master router will send hello message. Okay, you can mention this point as well here. And it support authentication as well. It uses multicast address 0.000.005e.00. after that group number, similar like HSRP. After that election criteria is also same like HSRP. First of all, they will check priority. So router who have highest priority, that router will become master. And if priority will tie, then they will check highest IP address. Okay, and by default priority is here also 100. Default priority is 100. Okay, and here you can mention one more point, that preemption is enabled by default. In HSRP, preemption is disabled, and preemption work for priority only. Preemption works with priority only. Preemption will not work with highest IP address, right? So always keep in mind that preemption is by default, preemption is enabled in HSRP, right? In VRRP. In HSRP, as we had discussed, that by default preemption is disabled. So you have to run one more command, that standby, group number and preemption. But here in VRRP, by default preemption is enabled. Okay, now guys, let me configure this network. This is my network where I am going to perform this practical. I am going to configure VRRP. So first of all, by default priority on all router will be 100. So priority will tie. So router who will have highest IP address, that router will become master. So this router will become master, right? This router will become master. But suppose this is my primary link. Here we have a speed of 8 Mbps. Here we have a speed of 4 Mbps, and here we have a speed of 2 Mbps. Right? So this is my primary. So what I can do, I can change priority on this router. I will set priority 110 over here. So this router will become active, not master. This router will become master. Okay, so let me discuss practically, guys. It will make you more clear. So let me open my GNS3. Here you can see this is my topology. Let me turn on the device, and I have already configured IP address on these devices. Let me show you very quickly. So here on ISP router you can see, and for connectivity, here for connectivity we can run any protocol as well, or you can configure NAT PAT with default route as well, right? We will discuss everything about VRRP in this video, don't worry. Let me show you IP first. So IP interface brief, exclude and assign. So as you can see over here, on serial 2/0 IP address is 2.1, right? This is your topology. On serial 2/1 IP address is 2.2. On serial 2/2 IP address is 3.2, and we have one loop back. Their IP address is 8.8.8. All interfaces are up. Fine. In the same way, I have configured IP address on router also. In my LAN, I am running which network? Here I am running 192.168.10.0 network. Fine. Here I am running 10.1 IP, here 10.2, here 10.3, and my virtual IP is 10.100, 192.168.10.100. This one is my virtual IP. So I will define this virtual IP address as a default gateway on this PC. Okay. Okay, guys, let's begin. So see on router 1 first of all. So IP interface brief, exclude and assign. So IP configuration is done. In the same way I have configured IP on router 2 also, router 3 also. Okay, and let me define IP address on this PC as well. Here IP address will be IP 192.168.10. Suppose 10/24, and default gateway is 192.168.10.100. This is my virtual IP that I am going to configure with VRRP. So checking for duplicate IP address, or you can say IP address of this machine is 10.10. Okay, now I am not able to ping my default gateway because my default gateway is not exist now. Ping 192.168.10.100. Fine. So I am not able to ping my default gateway because this IP address is not configured anywhere now, right? So go to router number 1 and let me configure. Let me start configuration from router 3. So how to configure VRRP? Command is go to interface F0/0, interface F0/0. Command is VRRP, after that group number. How you configure HSRP? Command is standby, right? Command is standby. So stand here in VRRP you will not run standby command. Here you will run VRRP. After that group number and then virtual IP address is 192.168.10.10.100. Okay, this is my, or you can see this router is master. This is master router. You can verify it. So VRRP. So VRRP. Here you can see state of this router is master. Virtual IP address is 10.100, right? And by default priority is 100. Okay, master router IP address is this one. Fine. So now my PC can communicate with default gateway, right? My PC can communicate with default gateway. So let me configure HSRP on router, VRRP on router 2 first. Go to router number 2. Yes. So IP interface brief exclude and assign. Okay, config T interface F0/0, VRRP group number 1 and virtual IP is 192.168.10.100. So VRRP. State of this router is backup. Fine. And virtual IP address is this one, and master router IP address is 10.3 whose priority is 100. Fine. Now let me configure HSRP on VRRP on router 1. Config T interface F0/0, IP VRRP group number 1 and IP is 192.168.10.100. Fine. So VRRP. State of this router is backup. State of this router is backup. So router 1 and router 2 is backup router and this one is master router. So PC can access internet via which router? Via router 3. But now I am not able to ping 8.8.8. So for connectivity I can run any routing protocol or I can run NAT PAT. So let me configure PAT. Right, in real scenario you will never configure dynamic routing here, right? So definitely you will configure PAT. So let me configure PAT here also. Go to interface serial /0 IP NAT outside. This is my outside interface. Exit interface F0/0 IP NAT inside. Okay, after that IP root 0.0.0 wildcard subnet mask 0.0.0 and exit interface is serial 2/0. Fine. After that access list 10 and permit 192.168.10.10.0 wildcard mask will be 0.0.255. In last video we had discussed this thing, right? How to configure NAT, how to configure PAT. So access list is done. After that IP NAT inside match from list 10 inside, and source match from list 10 and translate into interface serial 2/0 IP address. Fine. And you have to add, let me remove this command, one more command to run overload, to run PAT, that is overload. After that, do show history, and let me run same command on every router. Do show history. Let me run same command on router 2 also and router 3 also. Right. Let me paste it in notepad. Let me correct some information here, guys. First of all, interface, this one is inside, and before this one interface serial 2/0 IP NAT outside. Outside, then exit. Okay, so fine. Let me remove these two entry. Okay, so now command is fine. Let me copy it and let me paste on router 2 and router 3. Where is router 2? This is my router 2. Go to config T and paste it over here. Okay, so now you can see I am able to ping 8.8.8 or not. Ping 8.8.8.8 and source is 192.168.10.2. so yes, I am able to ping 8.8.8. I am able to ping ISP. Fine. Let me paste same command on router 3 also. Go to config T and paste it. Okay, so this router can access internet via LAN interface. You can verify it. Ping 8.8.8 and source is source interface source fast Ethernet 0/0. So yes, I am able to ping. Now my PC can also access internet. PC can also ping 8.8.8. Let me show you this one. PC ping 8.8.8.8. Right, I am able to ping 8.8.8. Let me trace route. Trace 8.8.8.8. So all my traffic is going via router 3, but this is my primary link. Here we have bandwidth of 8 Mbps. Okay, here we have bandwidth of 4 Mbps. Here we have bandwidth of 2 Mbps. Okay, so this is my primary link. So here we need to increase priority. So go to router number 1, interface F0/0, VRRP group number 1, and priority is suppose 110. Okay, so IP, so VRRP. See, now this is master router. Now this is master router. Router 1 is now master. Now if my LAN user will access internet, this is my LAN user. Now you can trace route 8.8.8 from PC1. Now see, my traffic is going via router 1. My traffic is going via router 1. And we have two backup paths. So this is my primary backup link. Right, here we have 4 Mbps speed. So here I will set priority 105. So go to router number 2 here and interface F0/0, VRRP group number 1 and priority 105. So VRRP VRRP. So this is backup now, but whenever R1 bill goes down, R2 will become master. Interface F0/0 says shutdown, and so VRRP. So VRRP, and a state is now init. Just wait. Now you can see here log message on router 2. Router 2 become master router. Now my LAN user will access internet via router 2. See, trace route 10.2. Next hop is 10.2, and this router 1 is down now, right? Router 1 is down now. So state is what? State is init. Interface down. You can see interface is down, and when again router 1 interface will come up, interface F0/0 say no shut, because preemption is enabled. So router 1 will again become what? Active, means master. See now log message, router 1 is now master and router 2 is backup. Fine. Okay guys, so now this machine can access internet via router 1. Whenever router 1 will goes down, my traffic will be shifted on router 2. When router 2 will goes down, my traffic will shifted on router 3, right? But again, if router 1 will come up, router 1 will become master. Router 1 will become master, because by default preemption is enabled, and you can verify that thing as well. How to verify? So VRRP, here you can see preemption is enabled. By default priority is 100, and here configure priority is 1010. Now how you will track? What will happen if this link will goes down? What will happen if this link will goes down? If serial 2/0 will goes down, or serial 2/0 of ISP will goes down. So how you can track this link? With the help of track. So let me configure track on router 1. Config T VRRP interface F0/0 VRRP group number 1 and track object is suppose 10. It's clear. Okay, and decrement when track will goes down, then decrement priority will be decremented by 10. Okay, priority will be decremented by 1 whenever track will goes down. After that, let me create track. So track object is 10, and why we are using this track interface to track which interface serial 2/0 line protocol. I want to track line protocol of serial 2/0. So even on router 1 serial 2/0 will goes down, line protocol of this interface will goes down. Even ISP's serial 2/0 will goes down, line protocol of this interface will goes down. If line protocol of this interface will goes down, then track will goes down. If track will goes down, then it will decrement priority by 10. Then it will decrement VRRP priority by 10. So track. Now you can see my track is up. Now track is up, so that's why. So VRRP priority is what? 100. But let me down serial interface serial 2/0 and say shutdown, and so VRRP. Now here you can see line protocol of track is down, So priority is 100 and configure priority is 110, right? And you can verify track, so track as well. So you can see track is done, line protocol of track is down. Okay, and so VRRP, here you can see priority is 100. So if now priority is 100 on router 1 and priority on router 2 is 105, so router 2 will become active. So router 2 will become active. You can verify it here. Trace route 8.8.8. So yes, I am able to ping 8.8.8 via router 2. But again, when line protocol of this interface will come up, let me run no shutdown command on this interface. Interface serial 2/0 and say no shut. Sorry. Interface serial 2/0 and say no shut. So again this router will become, track will come up, so track. Now you can see track is up. So it will increment priority by 10. So it will increase priority by 10. So VRRP. So again priority will become 110. You can see priority is 110. So this router will become what? Master. So again all traffic of my LAN user will reach to ISP via router 1. See, next hop is 192.168.10.1. okay, so with the help of in build track you can track line protocol of these interface. In the same way you can run track command on router 2 also, right? Track 10, track 10. After that interface serial 2/0, interface serial 2/0, and I want to track this interface line protocol of this interface. So line protocol, and now you need to use this track with VRRP. So interface F0/0 VRRP 1 track 10, and so track. Now track is up. Now you have to tell to VRRP that when track will goes down, decrement priority by 5. So interface F0/0 VRRP group number 1 track 10 and decrement by 5. So track is up. So VRRP, this is backup. So if router 1 will goes down and this router will become master, so when this router will become the master, they will track this link, right? In the same way you can configure track on router 3 also. And if you want to track ISP 8.8.8, you can use external track with the help of IP SLA. You can track 8.8.8 also. Let me show you guys. Go to router number 1, and here we need to configure one IP SLA and group number is 10, right? Enter. Then why we are creating ICMP for ICMP echo, and host is 8.8.8. so it will ping 8.8.8 and source will be source interface is serial 2/0 suppose. Okay, so this is my IP SLA. After that, let me schedule this IP SLA schedule 10, start time now, and lifetime is forever, right? So now I will use this IP SLA with track. So command is track 10 IP SLA 10 and reachability. Track number is 20 suppose. Okay, so track, now you can see there are two track 20 is also up, and I want to use this track with VRRP. So go to interface F0/0 VRRP group number 1 and track 20. This time track is 20 and decrement priority by 10. So if so, track. So if now ISP will goes down, this track will goes down, and when this track will goes down, VRRP will decrement priority by 10, so priority will become 100, so automatically router 2 will become active router. Go to ISP and let me set the loopback interface. Config T interface loopback 1 and say shutdown. So now if you will check here, so track, so track is reachability is up, wait for some time, after that track will goes down, this track will goes down. Once this track will goes down, VRRP will decrement priority by 10, so priority will become 100 and priority on router 2 is 105, so router 2 will become active. Okay, so track, this is problem of GNS3, it will not take much time. Right now you can see track is what? Track is down. So a state of VRRP change from master to backup. Now this is backup router because of track number 20 is down, so it will decrement priority by 10. So VRRP, here you can see priority is 100 and configured priority is 110. Okay, so now which router is active? Router 2. You can verify. Right, all traffic is going via router 2. Again, when ISP will come up, say no set, when ISP will come up, track will come up on router 1. If track on router 1 will come up, you can see reachability is up, this track is up, so this router VRRP will increment priority by 10 and priority will become 110 and this router will become master, and again router 2 will become backup. So again if you will trace 8.8.8, you can see all traffic is going via router 1. Okay, so no problem. If this link will goes down, if ISP will goes down, or if this link will goes down, this port will goes down, no problem, router 2 will become active. This is track in VRRP, and by default preemption is enabled, so that's why when router 1 will come up, it will become master automatically. Now if you want to configure authentication in VRRP, you can configure authentication. Command is same, interface F0/0, command is same like HSRP, VRRP group number 1 and authentication. After that authentication type text, right, a string. Okay, now if you want to change timer, so VRRP group number 1 and then timer, whatever timer you want to set. If you want to set advertised timer in millisecond, even you can do that. You can configure hello time in millisecond as well. 4. Make VRRP topology convergence faster, and interval you can configure interval from 1 to 255. So by default hello time is 1. Okay, so this is how you can change timer. So we had discussed track, authentication, timer and preemption. So preemption is by default enabled. Okay, so in the same way you can track 8.8.8 on all routers. And here if you want to perform load balancing in VRRP, again by default load balancing in VRRP is not possible. So you have to create 3 group. You have to create 3 group like HSRP. Okay. So guys, in next video we will discuss one more protocol, that is GLBP. GLBP, Gateway Load Balancing Protocol. In GLBP we can perform load balancing. Okay, so in next video we will discuss GLBP. This is all about VRRP. There is not much difference between HSRP and VRRP. First difference is HSRP is an Cisco proprietary protocol and VRRP is an open standard protocol. Second difference is HSRP is an layer 7 protocol and VRRP is an layer 3 protocol. Third difference is by default preemption is disabled in HSRP and by default preemption is enabled in VRRP, right? And track is same, authentication is same, and timer, how to change timer, these things are same. Okay, so where you will use VRRP? Whenever you have one Cisco device and one non-Cisco device. So on Cisco device, if all devices in your company are of Cisco, then you can configure HSRP. There is no any problem, right? But if you have non-Cisco device, in that scenario you have to configure VRRP. Okay guys, so that's all for today. If you like this video, please hit on like button guys. If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. In next video we will discuss GLBP protocol. Okay guys, thank you.